Welcome to the Corrective Corrosion channel. My name is Mariam. I'm a researcher in the field of corrosion and protection of materials. Chapter 4, Section 1, Electrode Kinetics and Kinetics of Corrosion, Polarization and Depolarization. The main references are Corrosion Engineering, McGraw-Hill Book Company, and Fundamentals of Electrochemical Corrosion, ASM International. The concept of polarization. Polarization is the change of potential from a stabilized state, for example, from the open circuit electrode potential as the result of the passage of current. In the simplest words, polarization is change of potential. Corrosion is an electrochemical reaction that occurs spontaneously. The rate of an electrochemical reaction is limited by various physical and chemical factors. Hence, an electrochemical reaction is said to be polarized or retarded by these environmental factors. Polarization can be conveniently divided into two different types: activation polarization and concentration polarization. Activation polarization refers to an electrochemical process that is controlled by the reaction sequence at the metal electrolyte interface. This is easily illustrated by considering hydrogen evolution reaction. Polarization is divided into activation polarization and concentration polarization. Usually, a mixture of these two types is observed. Types of polarization are considered as the causes of polarization. Activation polarization. Consider hydrogen evolution reaction on zinc during corrosion in acid solution. 2H plus 2 electrons yields H2. This figure schematically shows some of the possible steps in hydrogen reduction on a zinc surface. For this reaction, the species must first be adsorbed or attached to the surface before the reaction can proceed according to step 1. Following this, electron transfer, step 2, must occur, resulting in a reduction of the species. This step. In step 3, two hydrogen atoms then combine to form a bubble of hydrogen gas. Step 4. The speed of reduction of hydrogen ions will be controlled by the slopes of these steps. This is a highly simplified picture of the hydrogen evolution reaction. Step 1, Step 2, Step 3, Step 4. Concentration polarization. Concentration polarization refers to electrochemical reactions that are controlled by diffusion in the electrolyte. This is illustrated in this figure for the case of hydrogen evolution. Here, the number of hydrogen ions in solution is quite small, and the reduction rate is controlled by the diffusion of hydrogen ions to the metal surface. Diffusion of proton. In this case, the reduction rate is controlled by processes occurring within the bulk solution rather than at the metal surface. Activation polarization usually is the controlling factor during corrosion in media containing a high concentration of active species, for example, concentrated acids. Concentration polarization generally predominates when the concentration of the reducible species is small, for example, dilute acids, aerated salt solutions. In most instances, concentration polarization during metal dissolution is usually small and can be neglected. It is only important during reduction reactions. What is depolarization? Depolarization is the reduction of a counter-electromotive force by removing or diminishing the cause of polarization. For example, Depolarization removes the hydrogen gas surrounding the cathode and speeds up the corrosion process. 2H plus 2 electrons yields H2. Or oxygen reacts by consuming electrons at the cathode, causing cathodic depolarization and enhancing the rate of corrosion. Therefore, high levels of dissolved oxygen in water cause more corrosion. Half mole of oxygen plus 2H plus 2 electrons yields water. Corrosion can be controlled by prevention of depolarization and creating other forms of barriers such as coatings. In the depolarization process, depolarizers are used to remove hydrogen and therefore they help to keep the voltage at a high level in a polarization cell. For ferrous-based materials, oxygen depolarization is the determining factor in almost all cooling water situations, since pH is maintained at levels where hydrogen evolution effects are minimal. Polarization versus depolarization. For a non-passive system, for example steel in seawater, depolarizers increases corrosion current density or corrosion rate. The most common depolarizers are oxygen, acids, and the cations of less active metals. The left figure shows a polarization curve before the presence of oxygen as a depolarizers, and the right figure shows it after the presence of oxygen. Before the presence of oxygen, the corrosion current density is approximately equal to 1 microamperes per square centimeters. And after the presence of oxygen, the corrosion current density increases to the value of 10 raised to 5 microamperes per square centimeters. Challenge number 22. Thank you for your time and attention. If you'd like to challenge yourself, please answer this question in the comments below. Consider the polarization curves of oxygen reduction on steel in seawater in the presence and absence of factors that prevent depolarization, such as coatings on the metal surface, and compare the corrosion current density in the two cases schematically.